Assalamualaikum warahmatullahi wabarakatuh. Today I want to present about my group project with Power Electronics BNE 35203. My group members is myself, Ahmad Irfan bin Ahmad Shukran, DN 2004, Muhammad Shahid bin Mazlan, DN 2039, Muhammad Shahid bin Ramlan, DN 210115. My topic is DC to AC power converter which is specified full bridge power inverter. Introduction. Converting DC power to AC. A full bridge inverter is a type of H-bridge inverter. The number of components needed for the conversion is twice as high as it is for single-phase half-bridge inverter. A full bridge used for diodes and 4 switch-on circuit elements. By returning the energy stored in the load of the DC source, these diodes are known as freewheeling diodes or the feedback diodes. Circuit explanation. There is two methods, which is mode 1. Consider all the switch are initially off. By trigger T1 and T2, the input DC voltage will appear across the load. The current flow in clockwise direction from source to the series connect load. The output current across the load will be I/O equal to VDC per RL. Mode 2, transistor T3 and T4 are triggered immediately after completely commutating T1 and T2. The polarity of voltage immediately reverses after switching. Complementary switch T1 and T2 with T3 and T4. The DC input voltage across the load appear with the negative voltage, which is VO equal to negative VDC. We go to the operation of full bridge R and R load. There is 4 mode, which is mode 1. Resistor T1 and T2 will conduct between T1 and T2. T1 and T2 resistor will conduct current from the source to the load as soon as they are triggered. After actuation, the entire input voltage will appear across the load with a positive polarity, while the current will gradually increase until it reaches a peak value. Mode 2. In this mode, feedback diodes D3 and D4 conduct the load store energy back to the source. By contacting transistor T1 and T2, the feedback diodes will immediately begin conduction. For the mode 3, the transistor T3 and T4 are activated immediately following the discharge of an inductive load. By actuating T3 and T4, the current begins to flow in reverse. For the mode 4, D1 and D2 are the feedback diodes that will be conducting. Following the commutation of T3 and T4, this diode will begin conducting direction of the voltage. We go to the circuit design. This is the circuit design for full bridge power inverter. We have VDC, capacitor, switch, diodes, and R load and inductance load. Comparison of select power converter. We have full bridge and half bridge. Full bridge, a single description of full bridge. A single phase full bridge inverter is a switching device that generates a square wave AC voltage. Half bridge. The typical half bridge circuit consists of 2 control switches, 3 wire DC supply, 2 feedback diodes, and 2 capacitor. Number of components of full bridge: 4 diodes and 4 control switch. For half bridge, 2 control switch, 2 feedback diodes, and 2 capacitor. Size of full bridge is bigger. Half bridge is smaller. Efficiency for full bridge is 96%. Half bridge from 85% to 97%. Cost of full bridge is high, while half bridge is low. For advantage and disadvantage, for full bridge inverter, advantage is utilized in application requiring high voltage. Number 2, it has a bit higher voltage ripple than a half bridge converter. And lastly, it employs 4 diodes and rather than just clipping off half the wave. For disadvantage, low efficiency than half bridge. Number 2, the full bridge electrical converter is similar to the half bridge inverter. Lastly, full bridge would have greater losses and noise than half bridge due to the full bridge greater number of switching elements. For half bridge inverter, the advantage: magnetic coils are small. Next, no gap of the magnetic path. For disadvantage, they are operating at half the supply voltage. Yet, the collector current of the switching transistor is double that of the conventional push-pull system. And lastly, is not suitable for current mode control. This is simulation result that I simulate in PSpice. We have a VDC 100 volt, switch Q1, diode D1, switch Q4, diode D4, switch Q3, diode D3, switch Q2, and diode D2. So we conduct a measurement for voltage markers that we connect for each this circuit. For waveform, we get a square waveform for the DC to AC converter. For the calculation, the output RMS voltage. This is calculation for the output's RMS voltage, the instantaneous output voltage in a Fourier series, the fundamental RMS output voltage, the fundamental of output current function of time, and in the case of the resistant load, the instantaneous load current for this calculation. This calculation is used in a full bridge of power inverter. For discussion, we have four things that we apply in this discussion, which is applicability, strength and weakness, construction cost of converter, and power losses and efficiency. We go through to the first, which is applicability. Full bridge inverter is a topology of H-bridge inverter used for converting DC to AC power. The components required for conversion are 2 times more than the use in a single phase bridge inverter. Next, we go through to the strength and weakness. For strength of full bridge inverter is a consistent level of voltage across the circuit with no fluctuation, appropriate for use with high input voltage effective use of energy. The amount of current being drawn by the load is equivalent to the current rating of the power device. And the weakness is the efficiency of the full bridge inverter is just 95%, which is much lower than the efficiency of bridge inverter, which is 99%. High levels of noise, high level are lost. For the third, which is construction costs of converter, the circuit full bridge inverter use 4 choppers, each of which is made up of a pair consisting of a diode and either a transistor or thyristor and vice versa. And the cost is range between 222 ringgit until 5,000 ringgit. Lastly, power losses and efficiency. The power that goes into the input of the AC power. It is possible to gauge the effectiveness of rectifier by seeing how effectively it converts AC to DC. A high percentage of rectifier efficiency is suggestive of a good rectifier, while a low percent of rectifier efficiency is indicative of an inefficient rectifier. When it comes to judging the quality of rectifier, a high rectifier efficiency percentage is indicative of a good rectifier. Suggestion for improvement in this project: using snubber-less H-bridge power switches and improve DC to DC converter. For explanation, a high-performance DC to AC converter using snubber-less H-bridge power switches and improved DC to DC converter has been analyzed, model, simulate in MATLAB or Simulink environment, and implemented. Achieve our aim, we use reduced size of H-bridge inverter power switches with a less stressful DC power. Additionally, the system generates a constant DC boost voltage with less stress placed on both the source and the DC storage capacitor than is seen in traditional converters. Okay, lastly, for conclusion, therefore, an inverter is a piece of electrical equipment that converts a supply of direct current into a symmetrical voltage or alternating current AC, which on the output side has a standard magnitude and frequency. The kind of load that a single phase inverter is tend to manage determines whether it is a full bridge or a half bridge model. Full bridge inverters and half bridge inverters are two examples of this type of single phase inverter. Within the context of this essay, the phrase full bridge single phase inverter will be dissected. It is composed of 4 resistors and 4 diodes, which when coupled act as switches thanks to the device construction. Location that the switch is set to are what define the full bridge inverter's operational capabilities. So that's all for this presentation.